Welcome to a new episode of my Home Automation Open Heaven Node-RED playlist. In this episode I will be playing with ESP Easy again, and I'm going to use these 5 Sonoff devices, each controlling a lamp on the right, and I'm going to use the rules within ESP Easy to do various simple automations. I will put all the example code I'm using here into a text file, and the link to that file is available in the video description. Before we get started, let me say a few words about the rules. The rules are a piece of logic which is sitting inside the ESP, and it allows you to create some simple automations by, for example, turning the outputs on and off, monitoring some certain values, executing something on startup or at a specific time or after the delay has expired. So the instructions within the rules are fairly limited, but there is quite a few things that you can do. And most importantly, anything you do in the rules is executed by the ESP, so that works even if you don't have any internet connection or the connection is done for any reason. I couldn't really find an comprehensive write-up on the rules itself, but if you go into the ESP Easy wiki and then you scroll down to the command reference, you find a lot of stuff which you can execute from, well, not only from the rules, but from HTTP commands or the MQTT or over the serial ports as well. So I'm going to be working with some of these, and then with the actual scripting language. Before we do any work, first we need to go into the tools and into advanced, and need to enable the rules. So you enable that, you do submit, and the rules tab will appear, because otherwise it's not enabled in Sonoff. Sorry, not enabled in ESP Easy. Let's start from the beginning. You plug the Sonoff into your mains or into your power supply, it boots up, it connects to the wireless network, and then in most cases you might want to do something to happen right in the beginning. And this is what you can use the system boot option. By the way, what we are going to do in this Sonoff scripting is usually it's defined in these modules, which always starts with on, and after that it either comes an event or a certain variable state change, and then you type do, and then next you type the commands that you want to execute, and at the end of it you do end on, and you can repeat these segments for multiple events and operations and timers and everything. So to execute something on boot, you do on system hash boot or hashtag or at boot do, and then you do something and then you end on. And whatever I've done here is actually goes back to that command reference. So this particular device is an RGB controller. So what I wanted to do is I wanted to turn off all the outputs when the device boots up. Usually you can do this in the hardware as well, where you define the boot state of the GPIO pins. But in this particular case, it wasn't working for me, so I decided to do the system on boot. So because I'm controlling the outputs via PWM, I'm used PWM, the pin, and then the PWM value, which is anything from 0 to 1023. And to understand these commands, let's just go back to the command reference. And as you can see, there are a few stuff that we can use here, One of them is the GPIO, which is going to control a GPIO pin. So it can control an output to go high or 1 or on or off, which is a 0. And also if you want to control PWM, you have the PWM control, which is the PWM controller, like the fade control of a pin. And there are a lot of other stuff here, so you probably it's the best that you study each of them, because I'm not going to give an example for every single one of them in this video. So that's an easy example to do something on the boot. So set some variables to do something. Next, let's do something which is a little bit more complicated. In this example, we are going to use an input switch, and when the input switch is pressed, then we are going to set the output to low, so turn off the lamp, wait for five seconds, and then once that 5-second timer is elapsed, then we turn the lamp on. We wait for another 5 seconds, and then when the second timer is off, then we turn the lamp off. So let's check how it works in real life. So this is on of 5. So I click, nothing happens for 5 seconds, and the lamp comes on, and we wait for 5 seconds again, and the lamp goes off. This operation that we have seen is basically made of 3 steps. First, when you press the button, and then you wait for the initial offset, and then the second when you turn something on, and then the third step is finally when you turn something off. So this is also called like an on relay or an on and off relay. So after an event, it turns on after a specific time, and then finally it turns off. So the first line is on button hashtag state do, and what this means is actually this refers to a hardware setting. So if I go into into a device, if I go into the devices, I can see that I have one single device, and you see it's called button and it's called state, and these are the two. So in the rules, whenever we want to do something with a device, we are referring to the rule we are referring to the device as a name and a value pair separated by the hashtag character. So if I go back to here, the way I configure this device, it's an input device. The name is button. Again, index needs to have an index. On the son of the button is on GPIO 0. It has a pull up, so when I press it, it actually goes to 0, so it goes to low. And it's a switch type, it's a normal switch. I uncheck all the other checkboxes, and the value 1, so the switch only has one value, I'm calling it a state. So, what is important here is the button, the state, because this is what we are going to use in the script or in the rule, GPIO 0, the pull up, and yeah, that's pretty much it, to be honest. So let's go back to the rules. And oh, by the way, you can see that the state is 1. So it has sort of like an inverted state because of the pull up, the unpressed state is 0, and the unpressed state is 1, and the pressed state is 0. So going back to rules, on button hashtag state do. So this gets executed whenever the button state changes. So first we are checking if the button state is 0. So if and square brackets button state equals 0, then we do GPIO 12 so GPIO comma 12 comma 0. Again, going back to the reference, you have the GPIO command, which controls the pins. Sorry, wrong window, not this window, this window, yeah. The first argument is the pin number, so 12 is the relay pin, and 0, we want to turn it off. I mean, normally it's off, but we turn it off anyway. And then we set a timer, and the set timer command again has 2 arguments or 2 parameters. The first is the timer ID, and then the timer in seconds. So this is going to be a 5-second timer, and then we end the if and we end on. And to write the code which handles the this timer, we come to here. So again, on rules hashtag timer equals 1 do, which means that if timer number 1, which is here, expires, then what we are going to do is GPIO comma 12 comma 1. So we turn GPIO output to 1, so we turn the lamp on, and then we again create another timer. So this is going to be timer number 2, and again wait for 5 seconds. So the last on and on section we need to do is to handle the timer 2 event. So on rules #timer equals to do, and GPIO comma 12 comma 0 means turn off the relay. And this is what we have seen. I pressed the button, the button state was 0. I turned the lamp off. Well, because it was off, we didn't see anything. So we just wait for 5 seconds, and then the lamp came on. We wait for another 5 seconds, and then the lamp was off. So if I change this one to the first delay to 2 seconds, the second delay to 1, and I click, well, you can see that the screen has refreshed. So that's the only indication that the rules have changed. But let's head over to the bench and then see what happens now. Pressing the button again. So it was a shorter delay in the beginning and a shorter delay when the lamp was on. To understand this GPIO command a little bit further, let me just go back to the command reference. So it's GPIO, and then in the syntax it says cGPIO, and what it explains here is that how many ways you can control a pin on the on an ESP. So you can use the GPIO command, and the first parameter is the pin, and the second one is 0 or 1, whether you want it to be on and off. And you can use the PWM, which I used in the boot setup. So again, you say PWM pin and then level. So that level can be 0 to 1023. Actually, there is also another one which says pulse. So if you do pulse, comma 2, comma 1, comma 500, that would set output 2 to 1 for 500 milliseconds. So using these timers, I think it's great to set up long times, long on or off states, which can be multiple minutes or even hours. But if you want something really short, especially below 1 minute, so you can't below 1 second, because you can't put 0.5 here, then you need to use this pulse function. And there are some other functions as well, like servo, and then probably this document is not even up to date, because I know that the PWM can have like a third parameter again, which sets the fade time. So instead of turning something on to, let's say, a certain level immediately, you can give like a ramp up time or a ramp down time as well. As you can see from this example, with the rules you can create some really simple functions, but these functions are usually performed in many different ways, so it can be really useful. For example, you press the button, you want the pump to start, so you set up your initial state to 1, and then after 5 seconds you set it to, let's say, 0. You don't even start the second timer, and that basically creates an off delay. So that can be easily used to create, let's say, a pump. So you turn it on, you know that you need to run the pump for, let's say, 2 hours or 15 minutes to empty a cistern, and then it should shut off automatically. And of course you might say that, why I'm using an ESP for this, where I can buy a really simple timer. But I would say that, the ESP might just cost about the same as the timer. And if you have this device which is like tucked away and it's difficult to access, then managing it from the internet actually can be quite a nice and convenient option. I almost forgot to cover the easiest example, which is the local control of the relay. So you have, let's say, again, a son-of device which has a button and has a relay. So the obvious use of this hardware is that when you push a button, the relay comes on, and when you push it again, the relay goes off. And this is what you can see on the screen here. So again, on button #state do. So if the state of the button changes, then we are checking if the button state is 0. And if the button state is 0, we set the GPIO to 0 as well. So GPIO, 12, 0, else we set it to 1. And then we end the if, and then we end on. And this is all it takes to make the son-of respond to button switches, and then basically toggle the output of the of the relay, or the state of the relay. The only thing I noticed I had to do in this case is, in the switch configuration, I had to set the switch button type to push button active low. Otherwise it would just only respond to every second button presses. So let's see how it works in real life. It is not exactly rocket science, so you click and then it comes on, or you push, and then you push again and it goes off. And you can do it as many times as you want. And it works just like that. Now let's make it a little bit more complicated and do something which I think is really powerful in Sonoff, which is actually ESP Easy, is actually make two units talk to each other and send messages between each of them. So what I'm doing here is, again, I'm creating a function to respond to the button press. So again, on button state, and if the button state is 0, then set the output to 1. This line GPIO 13.0, this is the status LED. So you can use this to turn the status LED to match the relay state. But also keep in mind that in hardware, if you set the status LED to 13, then any network activity is going to then, blink the LED and then keep it turned on. So if you want the LED to solely reflect the relay, then remove this the status LED configuration from here. So again, let's go back to the rules. So I set the relay to 0, and then I set a timer for 5 seconds. And after 5 seconds, I turn the relay off, and then I do these two. So I'm doing send to 3 and, send to 4, event and start event. So what I'm doing here is I'm sending a message to unit number 4 to start an event, which is called So start an event which is called the start event. So first, let's just talk about this send to option. So if you are in the Sonoff, and if you go to Tools and Advanced, then you need 4 things, or a couple of things, for the ESP devices to talk to each other. First of all, they need an UDP port to talk on. And here you just have to specify a port which is otherwise not used in on your network. So I set 5600, but that can be any number of ports. And if there is any port conflict, you usually get some messages in the log. But okay, let's see some high random port. So you set that, and in here at the button, you come to global sync, and then you tick global sync. The other thing you do is you come to config, and in here you have a unit number. So this can be anything between 0 and 31, and that has to be unique for every device where you want to use this functionality. And if it's all set, then when you come to the main page and you scroll to the button, then you will see that you have all these devices are reporting their IPs and their unit numbers. Let me just refresh, because that 0 should be 6. So anyway, what we can see here is that the devices are now reporting their unit numbers, so they can be referred to, or they can communicate to each other using the unit number. So in this example, what I'm doing is I'm sending a command to unit 3 and 4 to start an event. And so next I need to call up the screen for unit, I'm just going to do one of them because they do exactly the same thing. So if you remember from number 2, we say send to 4 event start event. So on the target device, you do on and the event name do, and we set the GPIO to 12 to 1, and so that turns the relay on. We set the status LED off, which is again it reverse, so basically doing 1 is going to light up the LED, and then we wait for 5 seconds, and after 5 seconds we turn the relay off. So what is going to happen in this chain of instructions is that you press the button on son of 2, that would bring the relay on for 5 seconds, and then it will turn off, and then it will turn unit 3 and 4 on for 5 seconds, and then they will both turn off. So let's see how it looks in real life. So remember, unit 2 starts the cycle, so I click the button, the unit comes on for 5 seconds, then 3 and 4 should come on for 5 seconds. And what we can see is that unit 3 came on, but not unit 4. And this is something I've noticed with this send to communication, that sometimes the message is not really, well, it's not getting received. And maybe it's just the fact that they are too close to each other, and then I have these communication issues, but in other cases it works. And we know that unit 4 is working because we have seen the config page of unit 4 previously. So let me keep trying until it actually works, just to prove that it works. And I'm going to talk about that. And probably you can understand that, you know, with this functionality you can set up really complicated tasks by one unit starting something and the other thing starts, and it doesn't have to be a button press. It can be on boot, or it can be like a timer thing, which we are going to look at next. And now both of them came on, and then they will slowly turn off. Just to show that UDP communication is not the only way to communicate between devices, here is another example which does exactly the same as the previous one, but it just uses a different method. So besides using the send to command, there is also a send to HTTP command, which looks something like this. So send to HTTP, comma, the first one is the IP address and then the port number, so that's 80 for all the ESPs. And then to start an event you do /control $CMD equals event, start event. So you're sending out a control request. The command is event, start event. So previously we have seen is the with the send to option, it was sent to, you know, device ID and event, start event. So similarly, this is how it looks like if we want to send it over HTTP. So obviously the this example has the advantage of not communicating via UDP and not setting up, you know, global sync and then the ports and everything. But here you need to address the device using the IP, which is fine if you're using fixed IPs. If you're using dynamic IPs, that could be an issue. Next thing I wanted to show is time-dependent timers. So for this, again, we need to make a few system changes, configuration changes. So again, we go to Tools and Advanced, and we first we need to enable the NTP. So this is the service which synchronizes the clock of the ESP with the time server in the on the internet. So this would obviously need internet connection. You can define your own time server here, but if you just leave it empty, it's still going to work. And then you need a time zone offset in minutes. So I live in CT, which is 1 hour behind GMT, so I just put 60 here. And you notice there is a daylight saving time flag, so the ESP wouldn't know whether it's summertime or winter time. So once you do this and then you do submit, then when you come to the main page, then you will see that there is a system time, and that should match with your, obviously, with your local time. So going back to the rules, the example I created here is that it turns the relay on at 4 p.m. in the afternoon and turns it off at 4:10. And to do this, we only need a few lines of code. And here you go. So you can just ignore the start event because I was also using this device for the previous exercise. But the syntax is the following. So again, we have this on, do, and on structure. But here in the middle, we say clock #time equals, and now it says all, which says every day of the week. But this can be replaced with the weekdays in a 5-letter format. So MON for Monday, Tuesday, TUE for Tuesday, and so on, and SUN for Sunday, and with capitals, so MON, so something like this. So this would be every 4 p.m. every Monday, and this is 4 p.m. every single day. So it's the day, comma, and then the time in 24-hour format, and do, and then again I say GPIO 12.1, so the relay is on, and then at 6:10 I turn it off. The one thing to remember is this function cannot, so it only accepts equation. So at a specific time, it doesn't care. Care for minutes. For seconds. So it has to be specified as a certain hour and minute of a particular day or every day of the week. So there is no way to do months or anything like that, and less than or greater than it's not, it cannot be used here. So it's only equals and either all or the day of the month. And obviously you can have as many of these functions here as you wish, as long as you keep in the maximum 2k of the rule code. So as I said, in this rule you can always use the equation sign, which means that if your Sonoff goes off or loses power or reboots between these two periods, then this function will never execute because you have already passed, let's say, 4 o'clock. So for this, to cover this event, you might want to implement this logic. So you create a system boot function. So on system boot, let's say we just set up a 5-second timer, so it's not executes exactly on system boot, and the ESP might be doing some other stuff, but maybe with just a little bit of delay. So let's just a 5-second delay. So after this 5-second expire, then we check if the sys time equals is more than 16 hours. And here you can use the normal equations. Well, sorry, the less than or greater than signs as well. So if it's after 4 p.m., then we turn the relay off, and then if it's after 4:10, then we turn the relay off. The only small issue with this code that if your Sonoff comes on after 4, let's say 4:10, then this logic will make the relay to come on and then come off immediately. So there's going to be a a small spike or a split second when the relay comes on. But that's all. And so what is this sys time between the percentage marks? Again, we have to go back to the documentation, and if you go back, you find the system variables here. So there is only a few on them, and we have sys time. So this is the current time, and then the uptime and the so some of the other stuff as well. More importantly, the sys time contains the current time. So this doesn't have the part where it says whether it's a Monday or Tuesday. So this logic can only tell you a time within any number of days. So as long as you use all here, this should be fine as well. If you want to do only Mondays, then this logic is not going to work exactly. So again, you just need to consider this. Last, I want to talk about scenarios where you want to store some information, like you want to create, in a programming language, you want to create a variable where you store information, and then you can make decisions based on that value. And you can do that in ESP easy with the rules as well. But first of all, we need to create that variable, and this variable is going to be a device. So I've created this one, and you need to select dummy device. That's the device name. That's the device type, and then the name is, I've just given it counter. I've given it the variable 2, so that's the next one. The data type, I left it on single. And in this dummy device, you can actually have 4 different variables. So I'm just only using the one which I called count, and I set the decimals to 0 for all the others. So with this, I'm going to have a variable which is called name counter value count, and then it has a current value of 0. So let's come to the rules. I'm just going to scroll down because this is one of the devices I use for some other stuff as well. And in here, I haven't used the button for any action yet. So this is the son of 3, which is getting turned off once son of 2, sorry, getting turned on once the son of 2 turns off. So I've defined the a logic to handle the button pressing. So it's the same kind of button that I used before. And so if the button is pressed, then I check whether the button state is 0, which means that it's pressed. And I issue this command. So first of all, it's task value set. So task value set, and then the first variable is the task number, and then the variable number, and then finally the variable value. And in this line, we are going to learn two important. Actually, it's 4 o'clock right now, and this action, this rule just executed, so the lamp just came on. So yeah, back to the subject. So in this line, we are going to learn two things at the same time. So we can set a value by using this reference. So task value set, the task number, the value number, and then the actual value. And what I'm doing here is I'm reading the very same value and using the name value pair separated by the hashtag +1. So every time I press the button, this counter count value is getting incremented by 1. And the reason this is 2,1, because if I go back to devices, this dummy device is called number 2. So actually it's funny because this is using the task number, not the variable number. So just remember, so this is task 2 and variable 1, because this is the first variable. So you can have variable 1, 2, 3, 4, but I'm not using any of the others. So this is why it is task value set 2,1, and then the actual value, which is the, again, +1. So I'm incrementing. So then what I'm going to do is, if I press the button 10 times, I will turn the LED on. Turn the lamp on. So I create another rule which says on counter at hashtag count do. So if anything changes on this dummy value, and if it's more than 9, then I turn the relay on, and I'm going to set this value to 0. So task value 2, 1, 0. And I set the timer for 3 seconds, and when that timer expires, it's going to turn the lamp on. So what these 3 rules are going to do is, if I keep pressing the button, if I press it 10 times, it will turn the relay on and turn it off, and then the counter resets to 0. So again, I can press it for 10 times. It is it not suitable for very rapid inputs, but anything like, I don't know, maybe like half a second apart is going to be okay. So if I go back to devices, and so now it is showing count 0. So if I keep pressing this button, maybe you can hear in the click in the background. So 1, 2, 3, and by the way, this page doesn't automatically refresh. So if I click here, now we are at 3, and 4, 5, 6, 7, 8, 9. And we should be at 9, hopefully. Yeah, we are at 9. And damn, this lamp is on because of the timer. So anyway, I'm just going to press it again, and then after 3 seconds or 4 seconds, we should hear the lamp going off. So press, and the lamp is off, and if I refresh, the counter has gone back to 0. One more reason why this example is also important, because I mean, we have seen pretty much the same for the button presses as well, but now we have a variable which stores any, integer or floating point number, but this doesn't have to be like a a dummy value, because we will see later on. I'm planning to do some videos where I hook some sensors, for example a temperature sensor or another sensor, to the ESP, and then you can configure it as a device, and then you can create a rule which acts upon the particular value or the threshold of that sensor. So do something if the temperature rises above a set temperature, or do something if the temperature falls below a set temperature. And so then you can do anything here, trigger an output, or use the send command, or send to, or send to HTTP command to make another device to do something based on a condition being met on this device. So again, in this video we looked at like timers, setting something which is happening on a specific time, doing something happening on a particular event which is let's say triggered from another device, doing something after a certain timer has expired, storing something in a local variable and acting upon that variable, saying that variable is meeting a specific threshold or a condition, changing that dynamically within the rules. And quite honestly, I think this pretty much covers most of the the simple but everyday automations when you have to do something at a specific times, or two units needs to do something based on their relation or condition being met in one device, and another one needs to do something else, or just using the send commands do a series of actions which one device does something and the next one does something and the next one something. So think about an irrigation systems where each of your son-of devices controlling, let's say, a pump or a solenoid valve. So one zone turns off and then it turns off, and then the other next zone turns on, and then it cycles through the whole it goes through the whole cycle, and then each of the zones will turn on one after the other. I hope you find this example, the fairly theoretical example, useful, and you can use it in whatever application that you need to achieve. Thanks for watching, and see you in the next video.